Okay, so here we are at part 4, and the final part of section 3.9's homework. Question 47 is kind of a story problem in that it has words. So they give us the amount of radioactive plutonium in a 20-gram sample after T days, and they've given us the formula that would give us the amount. What they're asking me for is what rate is the plutonium decaying at time 2. And anytime they're asking for a rate of change, the rate of decay, that is just a derivative, because the derivative is a slope, and slope is a rate of change. So we're looking for the derivative of A, the amount, with respect to time. So, looks like I'm going to have to use my exponent rules, my A to the power rules. So, let's just dive into this and see what we get. So the derivative of A is going to be 20 times, and now I have to do the derivative of 1/2 t to the 1/40th. So this is the a to the u rule, and we know that the derivative of a to the u is a to the u natural log of a du dx. Okay, so check your notes. So by that rule, we should have the derivative of 1/2 to the power is simply going to be 1/2 to the power. And I'm going to rewrite that as 1/140th t times the natural log of 1/2. So again, a to the u, the derivative is a to the u, exactly what you started with, times the natural log of a. But I do have a chain rule, and again, I'm going to look at this as 1/140th t, so that makes the derivative simply 1/140th. So, cleaning this up a little bit gives me the derivative equals, I've got a 20 over a 140 times a natural log of 1/2 times a 1/2 to the 1/140th t power. So this simply reduces down to 1/7 natural log of 1/2 times 1/2 to the 1/140 t power. And they want me to evaluate this at t equals 2. So I plug in 2 to the only t, which looks like I get an answer of 1/7 natural log of 1/2 times 1/2. Plug in 2, I get 2 over 140, which would be 1 over 70. And I don't have my calculator handy, so I am going to say that this is our answer. Decimal might be a better answer in this case, so go ahead and finish that problem. And that brings us to the final question, and it gives us, it says for any positive constant k, so it's not a variable, it's a constant, the derivative of the natural log of kx is 1 over x. Prove it using the chain rule, and then try it again using logarithm properties first, and then taking the derivative. So the derivative of the natural log of k over x, using the rule for natural log of u, the derivative would simply be 1 over kx times the derivative of kx, which is k. So that reduces to 1 over x. Pretty simple. And then it says use log properties and do the same thing. So if we take the natural log of kx, we can simplify that to, using rule 1, the natural log of k plus the natural log of x. So now when I take the derivative of this, natural log of k is a constant, so that goes to 0, plus natural log of x is 1 over x, and we have, again, 1 over x. Okay, so that concludes all of the Chapter 3.9 homework. Out of 1 through 40, we only did every third problem. I would greatly encourage you to go back and try some additional problems, specifically maybe in the more complicated natural log problems, like the 28s, the 26, something like that, and make sure you get those under your belt. Okay, hopefully this has been successful, and that's it.